Good morning, students. Welcome to this problem solving session. Today, I will pick up the topic of work power energy. You can see I have this book opened, and the chapter I have opened is a work power energy chapter from NCERT. I'm on the NCERT website, by the way, and you can see this is work power energy. One of the problems that caught my attention is 6.29. This problem is unique. uh, it has been given in the chapter of work power energy, and the question is on potential energy graph uh, in a collision scenario, right? And when I read this problem, I find this problem to be slightly complex, because it is coming in chapter number 6, which is work power energy. And I will tell you, how to approach this problem and how to think about this problem. There are multiple things I want to share with you. I will not exactly say I'm going to solve this. I am going to solve this, yes, but I'm going to, make some changes because I'm not convinced with the question itself. Uh, and I'll tell you the reasons why I'm not convinced with this question. Okay. And before I do that, let me just, as usual, work on the concept part of it. And through this concept building, I'll tell you why I'm not convinced with this question. This question to me appears to be an incorrect question. It is an irrelevant question, and NCERT should actually change this question, and maybe articulate this question in a better manner so that it is easy for students to understand the question. The question is very poorly articulated, and when I say I'm going to do something about this question, I mean that I'm going to change the articulation of this question for the benefit of the students. Okay, so without further ado, let me just go back to the board and start discussing this problem with you. I hope you can still see it, and you know so let's get going on building the concept of this question. Okay, so the first thing is to read the question very carefully, and I will tell you the discrepancies in the question and why NCERT should worry about the quality of this question. So let's look at the question. So you have two colliding billiards ball. The situation looks like this, right? So you have one billiard ball, okay, and then the second billiard ball, okay, and these are undergoing an elastic collision. Okay, so let's say they were moving towards each other and they collide. Okay, this is the scenario of elastic collision. Okay, now what you're supposed to do is you have to draw the potential energy graph. You have to identify which of the following graph cannot describe the potential energy of this elastic collision scenario. Okay, so maybe the balls strike each other, so they're first approaching each other, they strike, and then they start moving away from each other, and there is a transfer of energy between the two balls. And we can always calculate, if you understand collisions, elastic collision, the energy remains constant, the momentum remains constant, right? So the in elastic collision, the kinetic energy remains unchanged. The momentum also remains unchanged. So there is absolutely no change in these two quantities. But the question is neither for kinetic energy and the question is neither from momentum. So these two, kinetic energy and momentum have completely been ignored in this question. And so the question is on potential energy, right? So which is to me a weird situation to be in. If I were to look into an elastic collision, I will just concentrate on two quantities, which is kinetic energy, and I will concentrate on momentum, right? So I will just apply conservation of kinetic energy before the collision and after the collision. They could have asked us to draw a graph of kinetic energy, and they could have asked us to draw, graph of momentum versus something. But what they've done is NCERT is asking us in a elastic collision scenario, they have introduced the concept of potential energy. And I just want to draw your attention to this whole thing. in an elastic collision. So if you have two bodies, mass m1 and m2, these could be small or big. If you have, and they are on the surface, let me just redraw this. Okay, this is a ball, and this is m1 and this is m2. If these two bodies collide elastically, and their initial velocity is u1 and u2, then after the collision, the velocities of the two body, this is m1, don't worry about the size, this is m2, the final velocities are v1 and v2. Potential energy has no place, note this down, has no place in an elastic collision, right? Whatever questions you have done so far, which are elastic collision, okay, elastic collision, do not have any, potential energy involvement. So these two bodies, when they collide with each other, there is absolutely no, kinetic energy, of which is conserved, is not getting converted into potential energy at all. It is not getting converted into potential energy. It is not getting converted into heat. It is not getting converted into sound. All of this could have happened if during the collision, you are having two bodies that collide inelastically, inelastically, right? In inelastic collisions, the kinetic energy gets converted into different forms of energy, or I should say, it gets wasted in different forms of energy, right? We still have some hope that in a collision, potential energy involvement could be there, but that is when you have inelastic collision. In our scenario, if you look into our question has a elastic collision situation. Okay, so elastic collision. So point number one, this question has good potential to misguide all the students into thinking that elastic collision, you know, has something to do with potential energy. And I'm telling you, elastic collision has nothing to do with potential energy at all. It is inelastic collision, and that too, drawing a graph is senseless. I think you can't draw a graph of an, unless it explains, every the distance between the two bodies and the relationship between the potential energy, how it varies with distance, which is what all the graphs are. So if you look into the graphs are potential energy and some distance between the centers of the ball, right? So these are the center of the balls, and so as the distance is changing, something is happening to the potential energy. But I mean, as I told you, elastic collision has no scope for potential energy to change. So where does the question of potential energy come in an elastic collision? It's senseless, right? So this particular question, has nothing to do with collision. This has nothing to do with, in fact, work power energy itself. This is a question which has no meaning, actually, and therefore I say that this is a question that NCERT should work on and should improve the language or the graphs or something about this question, that is easy for students to understand. Otherwise, this is very misleading kind of question for students. You'll get misled into believing that elastic collision has something to do with potential energy. All right, now let me take you further into this question. Okay, now the reality is that if you go to the chapter number, right, which is about gravitation. Okay, so let me tell you the chapter of gravitation. Okay, gravitation. In gravitation chapter, if you have a situation where you have two masses, okay, which are separated by a distance r, and let's say the distance is measured from the center of the the two masses, and this is the situation. The two bodies, we can call them point masses, where the mass is concentrated here. The gravitation chapter. So the chapter is gravitation, and you have a 2 point masses. Okay, 2 point masses are there, and therefore the in this chapter, which you may not have studied if you're in chapter 6, in chapter 6 you will not study gravitation. So I really don't expect that students who are doing work power energy should be able to solve this problem which I've just picked up today. Okay, you should be attempting this problem. I'm referring to this problem. Try this question 6.29 only when you have completed the gravitation chapter. Okay, now go to Google and search for the answers. Highly misleading answers, wrong answers, poor explanation. Please do not agree to any of the solutions which are given in Google search, right? I told you not to depend on Google Baba for your physics knowledge. You should look at explanation. I'm telling you, most of the, in fact, all the answers I saw on Google are incorrect. Nobody has bothered to explain there is no relationship between elastic energy and potential energy. Nobody has bothered to tell you that this question actually is from the gravitation chapter, and the concept in the gravitation chapter from where it has been picked is the concept of gravitational potential energy, right? So this is the concept you should know before you solve the question 6.29 in the work power energy chapter. The question number 6.29 in work point power energy is from the chapter of gravitation actually, right? So if you're not able to solve 6.29 in work power energy, please do not feel disheartened because you don't know what is gravitational potential energy. Unless you know what is gravitational potential energy, you will not be able to solve this problem. Now let me tell you what is gravitational potential energy. I will not get into detail of it, but let me just tell you, if you have 2 point masses, you can have n number of masses. What they do between themselves, they have something called as a gravitational potential energy, which is given by equation which is minus g m1 m2 by r. Okay, now what it means is the two bodies which are separated by a distance r are held at these two places. There is an attractive force, right, between these two which is trying to bring them, which is Newton's gravitational force between the two, r squared. So if you have force, okay, and this is a conservative force, and with the help of force you can find the work done when it moves through a distance, then you can convert the work done into potential energy by writing a negative sign. So that will be, so what we are referring to, V is actually potential energy, one and the same thing. You can also write it as U if you want to. The two masses between themselves, they are lying on earth, right, have between themselves a stored potential energy, right? And the question number 6.29 we're trying to solve today is from work power energy, is actually dependent on understanding of this concept. If you understand that there is something called as gravitational potential energy, you may be able to solve this, right? Otherwise, you will not be able to solve this problem, okay? I hope this is making sense. What it tells you is that gravitational potential energy is in fact inversely proportional to the distance between the two objects. So if you reduce the distance, you bring down the distance. And I'm assuming the graphs are essentially the graphs which are, let's go and see the graph, So if I look into the graph, I have 4 graphs. This graph, you can see, is potential energy versus distance. But the real relationship is the potential energy is inversely proportional to r. What it tells me is that the graph should be something like this, right? So if the bodies are very, very close to each other, they're close to each other, like they're colliding at this point, the potential energy between them, is the distance between them is practically equal to 0, right? So they're touching each other. Potential energy is going to be infinite because I'm going to put r is equal to 0 here. So if they're touching each other, so this is a state where they collide, they touch each other, the potential energy between them becomes infinity, right? So maybe like this, so it's like this. And then when they start moving away from each other, the potential energy starts decreasing. To me, the graph is something like this, right? So it tends to infinity, and when the distance tends to infinity, right, when r tends to infinity, the potential energy tends to zero. This is what I can make out from this graph. So this is your potential energy and this is your distance. So if you look into collision, in a collision scenario, the two bodies strike, maybe they start moving away from each other. The distance actually starts increasing, and maybe this is a situation, this is the new R, and then they move further. This is the new R. So at every point, R is changing, right? This is R1, this is R2, this is R3. The distances are changing, and the potential energy, therefore, is decreasing. So the concept is elastic collision has no role to play in this question at all. Elastic collision is meaningless. So therefore, I say that NCERT should worry about changing this question so that it's easy to understand. And if I go to the graphs, outrightly, this graph, the closest I can get is this graph, right? This is the closest I can think of. What doesn't make sense to me is what is 2R, right? So there is no explanation of 2R. Maybe this is radius of the two billiards ball, but what is 2R? Like they're touching each other, right? So this is when they touch each other, the distance between the center is 2R. At this point of time, the potential energy, gravitational potential energy, when they're touching each other, actually is, to me, unless they it becomes a spring energy and they bump into each other, they compress and change the shape of each other, which means one of the balls gets compressed due to the spring energy. This graph also makes no sense, right? Because at 2R the potential is shown to be zero, which is weird, right? To me, at 2R the potential energy cannot be zero. It has to be, in fact, very high, and less than 2R and beyond 2R, which means when the colliding balls start moving away from each other, the energy is shown to be zero, right? So even this graph is wrong. This is a sine graph. This shows that potential energy remains constant when the distance even goes below 2R. I don't know how two elastic colliding balls, what happens? Do they merge into each other? Then that's not elastic collision at all, right? Like a car merging inside a truck. So if you have a car, there is an accident and it merges into a wall, for example, it merges. That's not an elastic collision at all. So to me, each of this graph is making no sense. This is a sine graph. How does a sine graph come into a scenario of gravitational potential energy, right? What is this? This is the energy is first, going up as the distance is increasing. If the distance is increasing, the energy has to go down. So this graph is wrong. In this particular graph, the energy is constant throughout when the two balls are like merging inside each other and the distance goes even below. The centers come so close, the balls merge inside. That is not elastic collision. So senseless, right? This is senseless. Here, the potential energy is increasing with the distance. Senseless, right? Sine graph is senseless. This is the closest I could think is this, but even this is wrong. But I would just correct this graph to just what I've done. The 5 appears to be closest, but is not correct. Let me just repeat. This is closest to what I drew as my answer, which is this. My answer to this problem is this, right? If you can see, this is an U versus R. So this is like Y is inversely proportional to X, and therefore I can draw this. And I'm also taking magnitude. I'm ignoring the negative sign here, and so to me, all the choices which NCERT has given are wrong. The closest I can think of is the graph number 5, but even graph number 5 is wrong because it says that when the bodies are touching each other, like this situation where the gap between the two bodies is 2R, right? It's 2R. The potential energy is zero, which is, I think, absurd. The potential energy is there when the two bodies are touching each other. In fact, it is highest as per me. So to me, when R is zero, when the bodies are touching, when the distance between the two balls is the minimum is when they are touching. I call this distance maybe the minimum distance 2R. The potential energy is very high, which is contained. And as they start separating from each other, the potential energy goes down, right? sorry, it still remains in this quadrant, but it goes down. And when r tends to infinity, it tends to 0. So to me, this appears to be the correct answer. I would request NCERT to please look at this question carefully and not confuse the students. And also, in fact, shift this question from chapter number 6 to chapter number 8, because it makes no sense to include this question in work power energy. This should be shifted to gravitational potential energy. I hope I gave you some valuable insight today on this concept of gravitational potential energy. You could go to my playlist on gravitation, go through the concept of gravitation potential and gravitational potential energy. And I hope this also reduces your frustration of not being able to understand what is happening, because most of the solutions I saw on Google were incorrect. Please do not agree to those solutions at all. Do not memorize them. Use your own logic. The institutes which conduct this examination, NTA and AP Physics, or IB Board or CBSE, have some good physicists, good intelligent people making the papers. They will not do this mistake which NCERT has done. They will make a correct question. So go with my solution, because I think it's based on some rational and logic. My channel has around 2000 physics videos. The good part of my channel is all the questions are explained and solved. I'm just not giving solutions. I'm actually also pointing out a lot of mistakes done by many portals I saw. A lot of garbage which is available on Google, and my agenda is to help around 1 million student, benefiting out of my channel, and making career out of this. So if you score well, you get a good career, you have a good life, and you will prosper. But if you go with wrong solutions, will go with wrong portals, you may not be able to make good careers. Do not memorize physics. Always study physics from the point of view of explanation and then solutions. Just solutions themselves will lead to nowhere. It will lead to frustration only. Do not blindly agree to Google Baba. Thank you very much for your time, and don't forget to subscribe to my channel. And also today, go and watch my gravitational playlist. And if you have any questions, feel free to put them in comment sections. If you have some topic you want me to talk about or discuss, also I'm more than happy to help you in those topics. Thank you very much.